In the world of math, many strange results are possible when we change the rules. But there's one rule that most of us have been warned not to break. Don't divide by zero. How can the simple combination of an everyday number and a basic operation cause such problems? Normally, dividing by smaller and smaller numbers gives you bigger and bigger answers. 10 divided by 2 is 5, by 1 is 10, by 1 millionth is 10 million, and so on. So it seems like if you divide by numbers that keep shrinking all the way down to zero, the answer will grow to the largest thing possible. Then isn't the answer to 10 divided by 0 actually infinity? That may sound plausible, but all we really know is that if we divide 10 by a number that tends towards 0, the answer tends towards infinity. And that's not the same thing as saying that 10 divided by 0 is equal to infinity. Why not? Well, let's take a closer look at what division really means. 10 divided by 2 could mean how many times must we add 2 together to make 10, or 2 times what equals 10. Dividing by a number is essentially the reverse of multiplying by it in the following way. If we multiply any number by a given number x, we can ask if there's a new number we can multiply by afterwards to get back to where we started. If there is, the new number is called the multiplicative inverse of x. For example, if you multiply 3 by 2 to get 6, you can then multiply by 1/2 to get back to 3. So the multiplicative inverse of 2 is 1/2, and the multiplicative inverse of 10 is 1/10. As you might notice, the product of any number and its multiplicative inverse is always 1. If we want to divide by 0, we need to find its multiplicative inverse, which should be 1 over 0. This would have to be such a number that multiplying it by 0 would give 1. But because anything multiplied by 0 is still 0, such a number is impossible. So 0 has no multiplicative inverse. Does that really settle things, though? After all, mathematicians have broken rules before. For example, for a long time there was no such thing as taking the square root of negative numbers. But then mathematicians defined the square root of -1 as a new number called I, opening up a whole new mathematical world of complex numbers. So if they can do that, couldn't we just make up a new rule? Say that the symbol infinity means 1 over 0 and see what happens? Let's try it, imagining we don't know anything about infinity already. Based on the definition of a multiplicative inverse, 0 times infinity must be equal to 1. That means 0 times infinity plus 0 times infinity should equal 2. Now, by the distributive property, the left side of the equation can be rearranged to 0 plus 0 times infinity. And since 0 plus 0 is definitely 0, that reduces down to 0 times infinity. Unfortunately, we've already defined this as equal to 1, while the other side of the equation is still telling us it's equal to 2. So, 1 equals 2. Oddly enough, that's not necessarily wrong. It's just not true in our normal world of numbers. There's still a way it could be mathematically valid if 1, 2, and every other number were equal to 0. But having infinity equal to 0 is ultimately not all that useful to mathematicians, or anyone else. There actually is something called the Riemann sphere that involves dividing by 0 by a different method, but that's a story for another day. In the meantime, dividing by 0 in the most obvious way doesn't work out so great, but that shouldn't stop us from living dangerously and experimenting with breaking mathematical rules to see if we can invent fun new worlds to explore. For more mind-bending math, check out this playlist.